1900, Berlin, Germany. Christmas Eve. A 42-year-old physicist sits alone in his study. Outside, the city celebrates. Inside, he stares at an equation that should not exist. He has just written something that will destroy 300 years of scientific certainty. He doesn't want it to be true. He called it himself an act of desperation. But it was real. And it would change everything. His name was Max Planck. And on that silent night in Berlin, he cracked reality open. What he found inside would terrify him for the rest of his life. And it would give birth to the quantum world. The world that built your phone, your MRI, your solar panels, the laser that reads your data, everything. But here is what they never told you. He didn't believe his own discovery. He spent years trying to prove himself wrong. And when he couldn't, he had to face the most radical truth in the history of human knowledge. Reality is not fixed. It never was. It was always waiting for the observer. Let's go back. Further back. 1880s Europe. Science has never been more confident. Isaac Newton's laws have governed physics for over 200 years. Every planet, every pendulum, every falling apple, predictable, measurable, certain. The universe is a machine, a perfect, knowable machine. Scientists believe, genuinely believe, that they are almost finished, almost done, almost at the complete picture of reality. Lord Kelvin, one of the greatest physicists of the age, stands before the British Association in 1900 and says there are only two small clouds on the horizon of physics. Two small clouds. He doesn't know those clouds are hurricanes. One of them belongs to Max Planck. Max Carl Ernst Ludwig Planck was born April 23, 1858. Kiel, Germany. He came from a family of scholars. His grandfather and great-grandfather, both professors of theology. His father, professor of constitutional law. Order, precision, tradition. These were the values of the Planck family. Young Max absorbed them completely. At school he was exceptional, disciplined, methodical, not a rebel, never a rebel. A man who believed in the rules because the rules, he thought, reflected reality. When he told his physics professor at Munich that he wanted to study physics, the professor tried to discourage him. In this field, the professor said, almost everything is already discovered. All that remains is to fill in a few holes. Max Planck studied physics anyway. He would not fill holes. He would detonate the entire foundation. By the 1890s, Planck is a professor at the University of Berlin. Respected, precise, classical to his core. And he is given a problem. It seems, on the surface, simple. A black body. In physics, a black body is a theoretical object that absorbs all radiation and emits it purely based on temperature. Heat a piece of metal, it glows red. Hotter, orange. Hotter, white. Hotter still, blue. The question seems straightforward. Can we calculate exactly what radiation a black body emits at every temperature? They could not. Every equation failed. Classical physics predicted that as you moved toward shorter wavelengths, ultraviolet, the energy output should rise toward infinity. Toward infinity. That is not what happened in the real world. In the real world, the curve rises, then falls. Gracefully, predictably. But the mathematics could not explain why. Scientists called it the ultraviolet catastrophe. Classical physics was producing a result that was physically impossible, and nobody could explain why. This was not a small problem. This was a crack, running straight through the foundation of everything science believed about reality. Planck worked on this problem for years. He tried every approach classical physics offered, every mathematical tool available. Nothing worked. He was 42 years old. He had spent his entire career defending the classical view of reality, the continuous, smooth, predictable universe of Newton. And in 1900, he made a decision he described as an act of desperation. What if energy is not continuous? What if, instead of flowing like water, energy comes in discrete packets, fixed, indivisible units? He called them quanta, from the Latin, meaning how much. The moment he inserted this assumption into his equations, everything worked. The curve matched reality perfectly. Planck had solved the ultraviolet catastrophe, but the solution terrified him. Before we go further, if you are finding this story as powerful as I did when I first discovered it, hit that subscribe button right now. Every Sunday, the History Disruptors brings you another story of how one human being changed everything. If they did, you can too. Now, let's go deeper into what Planck actually found. If he did, you can too. December 14th, 1900. Berlin. The German Physical Society. Max Planck presents his solution to the black body problem. He stands before his peers, men who have dedicated their lives, as he has, to the classical universe of Newton, and he says something that changes science forever. Energy does not flow continuously. Energy comes in packets, quanta, and the size of each packet is determined by a constant, a fixed number that Planck has calculated with extraordinary precision. We call it today Planck's constant, h 6.626 times 10 to the power of negative 34 joule-seconds, the smallest meaningful unit of action in the universe. The room receives it with polite interest. They do not understand yet what he has done, and neither, fully, does Planck himself. Here is the part of this story that most history books skip entirely. Max Planck did not celebrate his discovery. He tried to undo it. 4 years after 1900, Planck worked to show that quanta were a mathematical trick, a convenient tool, not a description of physical reality. He wanted to find a way to reintegrate his solution back into classical physics, to show that the continuous universe of Newton was still intact beneath his equations. He could not do it, because what he had discovered was real. Energy truly does come in discrete packets. The quantum is not a mathematical convenience. It is the architecture of reality itself. And the implications, he saw them clearly, were devastating to everything classical physics had built. While Planck was trying to retreat from his own discovery, a 26-year-old patent clerk in Bern, Switzerland, was reading his work. His name was Albert Einstein, and Einstein did not want to retreat. In 1905, his miracle year, Einstein took Planck's quantum and ran with it. He used it to explain the photoelectric effect. the phenomenon where light hitting certain metals releases electrons. Classical physics said light was a continuous wave. It could not explain the photoelectric effect. Einstein said, "What if light itself comes in quanta? What if light is both a wave and a particle?" The photon was born. Einstein won the Nobel Prize for this in 1921. Not for relativity, for the photoelectric effect. For taking Planck's quantum and proving it described the nature of light itself. Planck had opened a door he never intended to open. And now, others were walking through it. Through the 1910s and 1920s, a generation of young physicists took Planck's quantum and built something extraordinary on top of it. Niels Bohr used it to explain the structure of the atom. Why electrons orbit nuclei at fixed distances. Why atoms emit light at specific frequencies. Werner Heisenberg discovered something even more radical. The uncertainty principle. At the quantum level, you cannot simultaneously know a particle's exact position and its exact momentum. The more precisely you measure one, the less precisely you can know the other. This is not a limitation of our instruments. This is not because we are not measuring carefully enough. This is the nature of reality itself. The act of observation, the act of measuring, changes what is being measured. The observer is not separate from the observed. The observer participates in creating what is observed. And Planck, the reluctant revolutionary, watched it all. He had wanted to preserve classical physics. He had wanted to save Newton's universe. Instead, he had ended it. And then, life gave Max Planck something no equation could solve. His first wife, Marie, died in 1909. His eldest son, Karl, was killed in World War I at Verdun in 1916. His twin daughters, Margaret and Emma, both died in childbirth. In 1917 and 1919. His second son, Erwin, whom Planck called the closest person to his heart, was arrested by the Nazis in 1944 for his involvement in the plot to assassinate Hitler. Erwin Planck was executed in January 1945. Max Planck was 87 years old. He had outlived almost everyone he loved. A man who spent his life trying to find certainty had found none. Not in physics. Not in history. Not in time. And yet, he kept working. Let us talk about what Max Planck's discovery actually built. Everything. The transistor, the foundation of every computer ever made, operates on quantum principles. Without Planck's quantum, there is no transistor. Without the transistor, there is no computer. No smartphone. No internet. The device you are watching this on exists because of what Planck wrote on Christmas Eve, 1900. The MRI machine, magnetic resonance imaging, uses quantum properties of atomic nuclei to produce images of the human body. Millions of lives saved. Every year. The laser, used in surgery, in communications, in manufacturing, in the barcode scanner at your grocery store, operates entirely on quantum principles. Solar panels, quantum physics. LED lights, quantum physics. The GPS in your phone, quantum physics. The electron microscope. The atomic clock. The entire technological civilization of the 21st century. Built on the foundation of one man's act of desperation on a winter night in Berlin. And we are still only beginning. Quantum computing, Machines that use the principles of superposition and entanglement to perform calculations impossible for classical computers is being built right now. Quantum encryption, communication that is physically impossible to intercept without detection, is being deployed right now. Quantum sensors so precise they can detect gravitational waves from colliding black holes a billion light-years away. All of it, every single branch of this extraordinary tree, grows from the seed Planck planted. The man who called his own discovery an act of desperation. The man who spent years trying to prove himself wrong. The man who accidentally broke reality, and in doing so, revealed a deeper reality beneath. But here is the discovery that goes beyond technology, beyond engineering, beyond the laboratory. The quantum revolution revealed something about the nature of reality itself. At the quantum level, a particle does not have a definite position until it is observed. It exists in a superposition of all possible positions simultaneously. The act of observation collapses that superposition into a single reality. The observer participates in creating what is real. This is not metaphor. This is not poetry. This is documented, verified, experimentally confirmed physics. Max Planck himself, in his later years, wrote, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." The father of quantum physics. The man who spent his career defending the objective material universe. Writing, at the end of his life, that consciousness is fundamental. That is not a small statement. That is everything. Pause for a moment. I want you to sit with that. The father of quantum physics, saying consciousness is fundamental. That matter is derivative from consciousness. What does that mean for how you see your own life? Your own reality? Drop a comment. Tell me what you think. Because this is the conversation that matters. And I read every single one. Now, let's talk about what this means for you. So what do we learn from Max Planck? 4 things. And they are not small things. Lesson 1. The most important discoveries come disguised as desperation. Planck was not trying to revolutionize physics. He was trying to solve a specific, stubborn, irritating problem that wouldn't yield to conventional tools. He made his greatest contribution not in a moment of inspiration, but in a moment of surrender to what the evidence was showing him. Whatever problem you are facing right now that will not yield to your conventional tools, that resistance is not a sign to stop. It is a sign that a deeper solution exists. One that may surprise you completely. Lesson 2. Truth does not require your belief to be true. Planck did not believe in his own discovery. He spent years trying to disprove it. He was wrong about his own work, and the work was still correct. Reality does not wait for our permission. The things that are true about your potential, your capacity, your future, are true whether you believe in them or not. Your doubt does not make them false. Planck's doubt did not make quanta disappear. Lesson 3. What you observe, you participate in creating. This is the most radical lesson of quantum physics. The observer is not passive. The observer is a participant. Where you place your attention, that is where your reality concentrates. Not as metaphor, as physics, as documented, verified, experimentally confirmed science. You are not watching your life unfold from the outside. You are participating in creating it, moment by moment, through the act of observation, attention, intention. Lesson 4. The reluctant revolutionary is still a revolutionary. Planck never wanted to overthrow classical physics. He loved classical physics. He was classical physics. But when the evidence demanded something new, he followed the evidence. Even when it terrified him. Even when he spent years trying to retreat from it. You do not have to be fearless to change things. You do not have to be certain. You do not have to want the disruption that is coming through you. You only have to be honest enough to follow what the evidence of your own life is showing you, even when it is an act of desperation. Here is my challenge to you. Max Planck faced a problem for years that would not yield. He tried every conventional approach. He was 42 years old, not young, when he finally proposed something radical. He spent years after that trying to prove himself wrong. He lost almost everyone he loved. He watched history do its worst. He kept working. And on a silent Christmas Eve in Berlin, his act of desperation became the foundation of the technological world you live in today. You are facing something right now that will not yield to conventional tools. Maybe it is a relationship. Maybe it is a business. Maybe it is a belief about yourself that keeps hitting a wall. Maybe it is a creative vision that the world has not yet found language for. What if the resistance is not telling you to stop? What if the resistance is telling you, like Planck's black body problem told him, that a deeper solution exists? One that requires you to let go of what you thought you knew about how things work? Reality was never fixed. It was always waiting for the observer. That observer is you. This is the History Disruptors. Every Sunday, another story of how one human being changed everything. Fleming found mold in a petri dish that the world ignored for 12 years. He kept it. Farnsworth saw television in the furrows of a plowed field at 14 years old. He built it. Planck wrote an equation on Christmas Eve that he didn't believe, that broke 300 years of certainty, that built the world you are living in right now. They all faced moments when quitting made more sense than continuing. They all carried something the world wasn't ready for. They all kept going. If they did, you can too.